Hi everyone, welcome back to our channel. Today we are going to solve this problem number 25. Find the Norton's equivalent across AB for the network shown below. So this is what we need to find out. Okay, so let us try to see the procedure of finding out this resistance value. Okay, see here. So load resistor is given. First, let's try to find out ISC. So how to find out IS is very simple. First, remove the load resistor and short circuit it. Okay. So I'm redrawing the network. So this branch is there. No, this branch we need to short circuit. Okay, and label this as ISC, and this is 2 ohm. This is 5 ampere. This is 5 ohm and 2 volts. So this is 2 volts and this will act as a new node which is nothing but Vx. Okay. So automatically now I need to find out ISC. But actually when you see here a short circuit parallel to an resistor will be equal to an short circuit. Okay. So by this it will get replaced. Okay. So I can redraw it. Same current source of 5 amperes is there, battery of 2 volts, resistance of 5 ohm, and directly the current doesn't flows in 2 ohm resistor, and current will only flow in the short circuit. So the reason behind is, so whenever these two are in parallel, automatically, or if you calculate, first value is 2 and this value is offering 0 resistor, 0 into 2 divided by 2 plus 0, resultant is how much? 0. So that's why the short circuit is also offering how much resistance? 0. So now this is the reduced network. Now we need to find out ISC. How to find out ISC? So in this branch the current is flowing like this. In this branch the current is flowing like this. Already current is flowing, already it is flowing. So this node is very crucial for us now. So to evaluate this, let us try to apply nodal analysis. Applying nodal analysis is nothing but applying KCL. Okay, at node. What is the node we require at Vx? See that how many entering currents are there? There's no entering current. 0 is equal to leaving current. Let's try to mark this current as some I1 and there's no need to mark for it. So this current I can write down it as I1 plus 5 plus ISC. So 0 is equal to I1. So how to write down this branch current? So current is leaving. So what is the leaving polarity of the voltage? Vx, and current is leaving. What is the leaving polarity? Minus Vx minus 2 divided by 5 plus 5. So how to write down this ISC? So we can directly write down the value of ISC. So why? Because directly we need to find out ISC value. So when you see here, this is shorted. Whenever this is shorted, this will act as an 0. Okay. So whenever you short it, what is the voltage now? 0. So 0 is equal to minus 2 by 5 plus 5 is equal to ISC. I mean ISC. So when you separate it, ISC is equal to 2 by 5 minus 5. So this will lead to an answer of minus 4.6 ampere of current. And come to this same network. So the procedure of finding R Nortons or R Thevenin remains same and inactive. So here I have an voltage source of 2 volts. We need to deactivate it. Deactivating it is nothing but make it as short circuit. And second one, we have an current source which is of 5 amperes flowing downwards. Deactivate this source is indirectly making it like an open circuit. Automatically current is zero. So resultant I'm going to draw here. So here I have a 5 ohm resistor, and this is the 2 volt source, and this will act like an short circuit, and again here it is open, and again you have a 2 ohm resistor. Okay, 2 ohm resistor, and we need to make it open. So the procedure of finding RThevenin is very clear. Why? Because we solve a lot of problem. Just short circuit this source, open circuit this source, and remove the load resistor and the resistance in from the open circuit terminal. So now you can see here the current flows like this, and current flows in 2 and current flows in 5. So if you have any confusion, mark this as zeroth node, and automatically this will act as an first node. Okay, so now 1 to 0, let's try to mark the elements and find out the value of RThevenin. So you can see here current is dividing. I can say these two branches are now connected in parallel. Whenever they are connected in parallel, it is nothing but product of resistance divided by sum of resistance, which is nothing but 10 divided by 7. Okay, so 10 divided by 7, we can find out this value. Okay, so just use your calculator and say this value. You will be getting this as 1.42 ohms. Therefore, this R Thevenin or Nortons is 1.42 ohms, and the magnitude of this current is already solved is minus 4.68 amperes. Okay. So this is the Norton's equivalent across the nodes A and B for the network. Wireless network, this is the closed path 1, this is the closed path 2, and closed path 3. That's why this is called as the network. It's very simplest method. So just we have to use our brain multiple ways and just analyze. This analysis is very important. So that's why I told. So short circuit parallel to resistor will be equal to short circuit. I'm repeating the problem. This will be equal to an short circuit. Automatically, what is the voltage at this point? Zero. So apply the nodal analysis. So 0 minus 2 by 5. Directly you can write down 0 minus 2 by 5, and leaving is 5, and next leaving is ISC. So I would like to solve this problem by one more way also. So this will create you an clarity of how to solving the problem. Okay. So you can have two sources in this problem. One is a voltage source and another one is an current source. Let us try to find out the next way of solving the problem. Okay. So by first method, this will be the method, and now I'm going to use method 2 of how to find out IESC value by using one more concept called as superposition theorem. Okay. So here you can see here how to solve it is. See here how many sources are there? Two sources are there. Okay. So I'm considering only 2 volt source is active, and I'm deactivating the 5 ampere source. This is like solving the same problem using source transformation. Okay. So now when you do it, okay. So for simplification, I am doing here. So these two sources are there. 2 volts is active and this is deactivated. Okay. Then automatically I can have the network with what is active now. 2 volts is active and this source is deactivated. Therefore, it acts like an open circuit with a resistance of 5 ohm. Okay, and now already short circuit parallel to an resistor, and the current is the same direction. Let's try to mark this current as ISC dash. Okay, so therefore ISC dash is equal to the current is flowing like this. What is the voltage? So current is leaving, or the leaving voltage, 2 minus 0 divided by R is 5, which is nothing but 2 by 5. This is finding out I short circuit dash when 2 volts is active and 5 amperes is deactivated. So this is A part and B part. Let us try to examine that here. So in the B part, what we are going to do is, so 2 volts we are deactivating and 5 ampere source we are activating. Okay, so when you deactivate this 2 volt source, what will happen is, this is a 5 ohm resistor and it will act like an short circuit. This is 5 ohm and this is shorted here, and only this current source is available. And already as discussed in the problem, short circuit parallel to a resistor is once again a short circuit. Now the current will flow in this direction. I am marking this current in this direction is ISC double dash. Okay, so therefore current doesn't flow in this path. Why? Because this is offering an high resistance. So the equivalent value, the current will flow only in this branch. Therefore ISC double dash is equal to 5 amperes. Therefore the total current as per superposition theorem is equal to ISC is equal to ISC dash and ISC double dash. Here you can see here the current is flowing from, so here the current is flowing from top to bottom, so mark it as positive. But here the current is flowing in opposite direction, bottom to top, mark it as negative. ISC value is 2 by 5 minus 5, which is of the same answer what we have been solved earlier. So here you are going to get minus 4.6 amperes. If you feel, if you want to solve the same problem by superposition theorem, why? Because the two sources are given, the answer is also same. Okay, so this is the way of solving by method 2 and this is the way of solving by method 1. Hope by any method the answer remains same. So if you want repetition, just watch the video, then you will get a clarity. So just the procedure of finding RThevenin is same. So you can see here by procedure 1 or procedure 2, the value of current is minus 4.68 and the procedure of finding R Nortons remains same. So successfully we have been find the Norton's equivalent across AB. So if you want to repeat, I will repeat the problem also. So this is open circuited, this is short circuited. I mean this source is deactivated and now this is activated and this source is short circuited, then you have only 5 ohm. Therefore I find the current in this branch, I find the current. So how to find the current is, so current is flowing like this. What is the voltage available? 2 minus 0 divided by 5. So here the current doesn't flow in this branch. Why? Because in short circuit to a resistor only one resistor is there, therefore the current will flow only in this direction, therefore ISC value is 5. So when you do this superpositioning, you should see the directions of flow of current. So here the current is flowing from top to bottom, which is ISC dash. Here the current is flowing from bottom to top, which is nothing but minus. So you can see by both the methods, answer is minus 4.6 and resistance value is 1.42. Hope you are able to understand the problem. So just by watching the video, nothing you get. Just watch the video, write down the given question and try to solve of your own. So if you feel my content is very useful for you, please like the video, please share with your friends, those who are watching the same subject or studying the same subject. If you have any doubts, let me know in the comment section. I can answer your doubts. And if you're watching the channel for the first time, subscribe to my channel KV Tulasi at the rate EV Crush, and kindly cooperate for the growth of this channel. Why? Because this is a free channel for the development of student as well as for faculty. Yours obediently, Ram, will meet in the another